All right, today everyone, we're going to do some Onshape. In particular, I want to show you all how to add the MKCad app and add feature scripts and a little bit about how and why we might use them. And so to do that, we are going to design a base, a pretty simple base. So a square rectangle of tubes with some walls, with some wheels and a gearbox. Hopefully at the end of this, you'll feel like you have all the tools, and it's just that you need to practice in order to get good at things. And if there's anything you need to go back to rewatch videos or practice on, definitely do so. It'll take a little bit of time before you really start to feel good and comfortable with it, but you should have all of the tools that you need for almost everything that we do with Pearadox relating to Onshape and CAD. So you're going to sign into your Onshape. You're going to go to Create Document. And actually, you know what? We don't even need to do that right away yet. The other thing that I want you to do is go to Onshape for frc.com. And so that's Onshape for like the number 4 frc.com. And then click this Getting Started. And that's just because they've got a couple of links that we're going to use here to get going easier. So there's this Onshape App Store link for MKCad, for the MKCad app. And so you're going to right click on that and you're going to go subscribe to it. So you're going to hit that blue subscribe button, get for free, don't leave the page, and then you're going to close out of it. Something that I have learned is, I'm going to go just into an example here. And in this assembly, when I did this earlier for a test, probably have to refresh here to get the MKCad app to show up. There it is. So now there's this button over here on the far right hand side called MKCad Inserter. So when you click on that, that brings up a panel on the right hand side. And you'll need to make sure to hit Authorize Application. When I did this earlier testing, it didn't bring this up and it wasn't working and I couldn't figure out why. I had to close my browser, sign out, and then sign back in. And then when I tried to use it again, it asked me to authorize the application and then it started working. So you can see that I can go now and add things into the document from here that have already been made. And so if there's a gearbox that we could go and buy or wheels that we could go and buy and use, we can just insert them into assembly from here and it goes and does that automatically. It makes our life a lot easier doing some of this stuff. So I'm going to go back into Onshape and I'm going to create a new document now because we're going to just do a test space. And so whatever you want to name your document, it doesn't really matter. But if you've added the Onshape app and you go into assembly, again on this right hand side, you know what, I'm going to start a tool that helps to see where I click. There we go. So you can see I've got an orange click when I left click and a right click when I blue click, or blue circle when I right click. And also as I type keys, they'll show up in the bottom. So when you click on that MKCad, that brings up a panel along the right hand side. And so go ahead and just try to insert something to make sure that it actually works. If it doesn't, go ahead and close out of your browser, sign out of Onshape and come back in. We're not going to actually use this, so I'm going to select it over here and delete it. And we're going to go back into our Parts Studio. So what we're going to do is we're going to first start with a sketch, and I'm going to show you 2 ways that you can go about something. Obviously there's more ways than this, so you could do every part kind of individually. I'm going to do some center point rectangles to make our general shape of a base that we're going to do. So I'm going to go here, here, and here. And so you can hopefully kind of imagine now that these 4 rectangles along the side would make up the external base of the robot. And so we could complete this sketch and we could go extrude every one of these. They need to be 2 inches. So new. And then I have to go unhide the sketch, and I could do this one and also do this for 2 inches. And I'd have to do the same thing again for this one, new. I'm not going to do it as 2 inches, but you can see, whoops, I did those all as add somehow, even though I was saying to do them as new. Just didn't click. So you can see that these are all now 3 distinct parts. We'd have to go and do some other things to make them be like a tube where the inside is cut out. We could come in here if we wanted to and make a sketch along here. Oops, I've still got the center point. That's my bad. Let's undo that sketch and let's go do a regular corner rectangle. So I could come here and then I could do some dimensions of how far it needs to be, 0.1, and this should be 0.1 from this line, except I'm going to say minus 0.1 so that it goes under. And then same thing for here, and let's make it minus 0.1. There'd be better ways to do it, but I'm just showing this as a example. Then you could go and remove this, and we could just do through all. And so now, we would have a tube here, and we'd have to do the same things to the other ones, and etc. But fortunately, through excessive use of feature scripts, we can do this much easier. So what a feature script is people can make their own custom tools, kind of like what we have with Extrude or some of the sketches or whatever, things like that. And there are some smart people that have gone and done things to make our life a lot easier. And so if you go back to the getting started of Onshape for FRC, we're going to come down to this list of useful feature scripts, and you can right click and copy link address for this Julia's feature script, because we're going to take a couple of these. And when you look over here along this far right hand side, you'll see this plus around a dotted square. And so when you click that, you can add custom feature scripts. So we're going to paste that link for Julia's feature scripts in here, hit enter. And so these are some feature scripts that someone named Julia has worked on. We're going to use Extrude Individual. So you're going to expand that and then click here, and that will add it. And you'll see that it showed up top right next to the Add Custom Feature Scripts. We're also going to use Tube Converter. So we're going to expand that and add it. And we're also going to use, let's use the Shaft Generator. So we'll do that and add it. So there are other ones in here that you can absolutely use. We use several of them, but those will be 3 that we use for today. So now that we've added those, we can now see that they are buttons just like anything else. They've even got some nice icons for them, which is really great. By default, they just have some numbers or letters or anything. There's some things like that. But let's go back and do the sketch again. So I'm going to go do the center point rectangles from the origin, and we'll go just like this again. And so I'm going to do a little bit more to make it like the real thing. We need this distance to be 1 inch, and we need this distance to be 1 inch. And let's make our whole base be, we'll just make it a 25-inch square. So we'll say 25 by 25. So the nice thing about this now would be that we could go and modify how long or wide the robot is pretty easily. So we'll hit check mark there. Now this is completed. And now we're going to use this Extrude Individual feature. So when we click this, you can read a little bit about what some of these things do. Actually in our CAD document. So if you go to Pearadox 5414.weebly.com, under more, under Pearadox resources, we have our CAD document. And in our CAD document, we have some recommended feature scripts that people on our team have used and think are definitely things that we want to continue using. So let me see where here we go. So there's a little description about some of these things so that you can see there's Tube Converter, Gusset, Spacer, Shaft Generator, Extrude Individual may not, oh here we go, Extrude Individual is listed in here. And so yeah, we're going to select the sketch regions for the Extrude Individual. And so you can see that when I select those sketch regions, it extrudes every one of them individually. So now there's 4 individual parts. I need to go back into it and extrude it to 2 inches though, because we use 1 by 2 tubes. And And so that makes it a lot less work. And then to make the next thing even less work as well, we can go and we've got this tube converter. So basically now we're going to go select the parts that we want to turn into tubes. And it turns these guys into tubes. And we don't need a hole pattern on this. We can use a hole pattern if we want to. Oftentimes we do not. Oops. I think I may have just accidentally done something. Okay, there we go. So these are still tubes, which is great. And yeah, so you can see it even renames them so that we can see their thickness and all that. I did miss that. Wall thickness at 0.125, that's probably fine. We could do it at 0.1, or we could do some tubes a little bit thicker or thinner. So that wall thickness is just how thick these walls are. So depending on what it is that we buy, we would want to use different parts there. Okay, so we now have this base, and so we do need to go and add a couple more things. So I'm going to do a sketch on one of these side rails. I'm going to hit N to do view normal to plane. I'm going to add a construction line, so L and Q. And so again, a construction line is useful when you want to see some geometry, but you don't necessarily want to have a feature based off of it. And we'll add a midpoint on here just so that we can see it easily. And I'm going to make some construction circles to be representative of our wheel. So let's say that we want to use 4-inch wheels here. We could come here and make that be a 4-inch wheel, and we can see roughly how big that wheel would be. I'm actually going to delete that. And we are going to add some bearing holes. So in a lesson that we'll do some other time, we'll show why it is that we do this, but I'm going to create a bearing hole, and our bearing holes are 1.124. That's something, again, you'll learn those dimensions later, but that's just how big that hole needs to be for us. And we're going to make it be 1/8 of an inch below the center line. And then we're going to make another circle somewhere over here on the actual center line. And we can make the bearing holes be equal in size. I'm going to add a line here to be our middle point axis here. Again, that's a construction line right here. If I were smarter and remembered things, I would know that our gearbox requires some holes, some distance here that I don't quite remember what it is. So I'll make some dimensions here for right now, and we'll go and fix those later because I don't actually remember what those are. That's probably not it, but that's fine. We'll do it like this for now. And is that it? Oh, the other thing that we want is we want this dimension. And when we make this dimension, we're actually not going to do it to the center point here. I'll go ahead and real quick make another construction line just to make it real obvious what it is that we're doing a distance between. So this blue line here is what we want to dimension. And that's because we want chain to be a certain length long. We usually do in quarter or half-inch increments plus 0.018. We add that extra distance there. So I have 10.018, and maybe just to make sure that a wheel would fit here, I'm going to make a 4-inch circle. And so you can see that that wheel would be in the middle of here. Maybe that's fine. Maybe we want to extend this out some point, so maybe we would need to move it back. I'm going to leave it like that for now. All right, so we can now use the mirror tool. We can do that, and if you hover over, or you can see it's telling you to select a mirror line, so we're going to mirror things from here, and we're going to take these points, and now all that is mirrored across the center point here. So we can see where the wheel would be, the bearing hole's already there, and we're going to remove these circles. And so remove through all. And so we can also merge scope. We can click merge scope here and select this part. And so now it adds those holes in that tube as well. All right, so we are pretty close to done in our part studio here. The last thing that we'll do is just show the shaft generator. This isn't too important for what we're doing as far as learning, but it's just one more example to do it. So we're going to use a 1/2" hex. We can change the retention type. We usually end up doing a retaining ring and with an E-clip. And we would have to go and figure out the actual dimension, but right now I'll just say it's 4 inches. That might not end up being exactly right. And you can see that it ends up putting it at the origin, but we can come over here and instead select that we want it to be at one of the things there. We could go and make a plane offset from here so we could really have it roughly in the right place, whatever. Okay, so that should be just about everything that we need here. I'm going to go into this assembly now, and we are going to insert almost everything. I'm not going to insert the shaft. Actually, we'll go ahead and do that. Let me exit out of here. Let's minimize that. We could just go insert part studio. And then we can do one of a couple different things. We could go and mate all these parts, or because we know that they are where we want them to be because of how we design them, we can go and select them and then do a group mate, which is this guy here. And so they are now grouped together, and I'm going to go and fix one of them. And so now you'll see that the shaft can still move, but nothing else can move relative to one another. So now let's add a couple of things into our assembly here. So in the MKCad app, we are going to go add some bearings. And so we need a 1/2" hex 1.125 flange bearing. So we're going to need 2 of those. So I'm going to select those 2 for right now. And you can see that they showed up in my list over here in the assembly. And we're going to fasten these. So this might be, let's minimize that. I'm going to go ahead and move these roughly to where they're going. I don't know if it's going to be in the right space or not. And so if I go here, I can fasten, and I can select this center point and here, and you can see those mate. I see it, lost one of them. You can see the mate connector show up there. Oh, I just clicked the wrong thing. I need to do a fasten mate from here to there. And I need to flip that around so it goes in the tube. I can hit OK, and I can see, okay, that all looks good. I've got the right mates. Let's do the same type of thing here. Again, I'm going to take the center of the bearing on that face, and we're going to put it up here. Flip it. Looks good. And then let's do we'll do a revolute mate, and we'll go here, and we want the center of this guy here. And I'm going to do an offset. So we would have to go and figure out what the real offset needs to be. Let's see, we'll do 2 inches for now. Okay, the other things that we'll need are going, oh, you know what? Actually, I'm going to remove that revolute mate. We're going to do something else. We're going to go back into MKCad app. We're going to look for a wheel. So I said we were going to use 4-inch wheels, so let's come down and look at what 4-inch wheel options we have already in here. We could use Omni wheels. I'm going to look for a 4-inch Coulson wheel, if I can find it. I've probably already passed it. Okay, I must have passed it. Here we go. 4-inch wide. Okay, 2 inches is probably wider than we really want. There's probably one for something thinner, but here we go. 4-inch OD, half hex, bore 1.5 inch wide. That'll be great. So I've inserted one of those. If we go and look at it, you'll see, oh, it's already got stuff for the hex. Great. All right, so now we can go and do a fasten from here to the end of this hex. Actually, that's not quite where we want it. Let's we want to go to the center of this hex so we can make sure that the retaining ring fits on. So you can see the hexes don't quite line up, but we know it would fit, so it's not really a big deal. We would probably really want to go and add a spacer between here, or at least in this fasten mate, and go and do an offset a little bit, so we could do like 0.1 or something like that. Oh, that needs to be minus. So that we can be comfortable getting that E-clip on and off. And then now we can have an idea maybe about how far we want this revolute mate to be. So this is a 1.5 inch wheel, so let's just take the center of this to the center here, and let's do an offset of, do 1.75. Solve. How does this look? That's a little tight, but for what we're doing, yeah, that's probably too tight. Let's go back into our revolute, and we'll just make it a full 2 inches. So now there's some space there. We would want to refine that a little bit. And then on this side, we would need to add some sprockets to get to gearboxes. But the last thing that I want to show y'all is this replicate tool, because it can be pretty handy. So we can select instances that we want to replicate. So we want to take this wheel, we want to take the shaft, and then we want to take both bearings. And then we want to say where it is that we want to put it on. So I'm going to switch to the faces to find match on. And if I make it match faces over here, must not like doing the bearings. Interesting. It's not quite what I thought was going to happen. Let's try this again. Replicate. Very interesting. I don't know what is going on with that and why that's so backwards. I guess it's kind of giving me this indication that this blue thing is where it's matching on, and I'm not quite sure why. If I go back into the instances, can I select this and add it? Nope, I can't. So let's remove that. So we've at least saved ourselves some time with inserting these things. I wonder if we can go and then replicate this instance on this face, and there we go. So we've now at least completed that. The other thing we can do if we wanted to is we could go, and I'm going to remove these two things, and we'll make a new assembly. And we're going to add two of our assembly ones. I'll fix one. I guess maybe I need to select an individual part in it. Just going to fix this. And then we can go and do, say, a fastened mate on here to here. And so we can see that's not quite the right rotation, so I can rotate it around a couple times, hit solve, and then it went, and now we've got that completed. And so just wanted to show y'all a little bit about that. really what we would need to do here is we don't want to replicate all this here. We would, let's go and edit this replicate. I'm going to double click here and we're going to remove, oh, I guess maybe we can't use a replicate because it's going to try to use that hole and we don't want it to actually use that hole. What we really need to do is go and remove this and do a gearbox and pick whatever gearbox it is that we want to use. I'll use this one as a for instance. And then we could go and mate the output shaft of this gearbox. Getting all turned around with my mouse here. Actually, let's delete this replicate too. We want this whole here to line up with that hole there, and we need it to go the opposite way, and we need to rotate it, and we don't need both of these here right now. Oops, wrong one. Let's delete this one. Because we would then want to put a wheel on here and then have that replicated. Let's do a test real quick just to see if I replicate, does it avoid doing things that are already taken. Nope, it does not. It's not smart enough. So we would have to do things the slightly longer way, but we can always go and make, we can grab these things and this, do Control C, Control V, and now we've got another one and we could group them together. Whatever, things like that. It doesn't like this, I guess, because of the revolute mate. But yeah, there's things that we can do there to make our life easier. So anyways, go ahead and spend a little bit of time making a complete base. It won't be fully complete because what we would really need to do is add a rail because the wheels can't be the outermost part of the robot. But this is at least a start to kind of help get everybody going with stuff. So that's it for today. All right, thanks. Bye.